This jump demonstration shows how to evaluate and compare experimental designs. We'll use an example from a JSL script that can be found by going to Help, Sample Data, and clicking Open the Sample Scripts directory, where we'll then open and run compare same run size.jsl. This creates two 13-run experimental designs, a definitive screening design and a Plackett-Berman design. Let's evaluate just the Plackett-Berman design to start. Most of JMP's DOE platforms provide built-in design evaluation tools that we can also access from design tables by either running the auto-generated evaluate design table script or by selecting the table and going to DOE, Design Diagnostics, and choosing Evaluate Design. We'll put our 6 factors into the X factor role and the response into the Y response role, and then we'll click OK. The design evaluation report provides a number of specific diagnostics and tools. To highlight a few, we have a power analysis tool to determine the probability of detecting effects of a certain size, assuming that those effects are actually active at that size. There's also a prediction variance profiler that allows us to explore the variability in predictions across our factor space. And the alias matrix and color map on correlations help us identify strongly aliased effects, given the design. Design evaluation helps us assess an individual design, but now let's use design comparison to determine if we prefer the Plackett-Berman design or the definitive screening design. We can start from either design table. We'll start from the Plackett-Berman table, and then go to DOE, Design Diagnostics, and choose Compare Designs. The Plackett-Berman design is now our reference design, and we can choose one or more additional designs for the comparison. We'll select our definitive screening design table and click OK. The resulting report has similar structure to the Evaluate Design report, though now displaying diagnostics for both designs side by side for our comparison. We can compare the power of the designs, their prediction variance profiles, and their aliasing structures, among other diagnostics.